Bismillah ar-Rahman ar-Rahim. Now we'll continue with this problem. I will do this example, which is a question from the book. It has this series. And he says the next exercise used to determine the number of terms required to the sum of the series with an error of this less than this. Okay. The first things which we need to do, we need to show that this series is satisfy the conditions for alternating series. So what is an? An is 1 over 2 n cubed minus 1. An very clear is positive. Okay. Limit an as n goes to infinity. That will be very clear. 0. Also, an plus 1 is 1 over 2 n plus 1 cubed minus 1, which is, yeah, we know that 2 n plus 1 cubed minus 1 will be greater than 2 n cubed minus 1. This is an, yeah. So 1 over will be less than this. So I have an plus 1 less than an, and this is what I want. So all conditions are satisfied. So the series, this alternating series, will converge. Good. Now we'll go to the, we want the error to be less than this. So I have what? We have S minus capital S capital N, which is less than a n plus 1. And what is, and I want this to be less than 0.001. So what is a n plus 1? It will be 1 over 2 n plus 1 cubed minus 1. And that I want it to be less than 1 over 1000. That means I want 2 n plus 1 cubed minus 1 greater than 1000. So I want 2 n plus 1 cubed greater than 1001. So I need n plus 1 cubed to be greater than 1001 over 2. So I need to choose now what will be my capital N. Okay. My capital N, if we check, let me start with what? 5, for example, n equal 5, what will be that? 6 cubed. 6 cubed is what? 36 times 6, which is 216. Yeah, this is approximately, what exactly it is, 550, 1,500, I mean 500.5. This is 1,000 over 2 plus 1 over 2, which is 5,500.5. So this is will not reach it. N equal 6. So I have 7 cubed. Okay. 7 cubed will be what? Will be 49 times 7. That will be what? 7 times 9. That's 63. 328 plus 6. 28 plus 6, that will be, is it? Yeah. 36. 7 cubed is 49 times 7. Yeah. That will be 343. Yeah. Which is still, I'm not reaching this. What about capital N equals 7? We have what? 8 cubed, which is 64 times 8. That will be what? 8 times 4, 23. 648, that will be 51. So this is, give me 8 cubed, which is 512, which is very clear, greater than this. So this is okay. So my n is how many terms? How many terms? We need at least 7 terms. Yeah, at least 7 terms. Usually in the exam, they will ask about the minimum number of terms, which is 7 in this case. Let me do this one. The given alternating series is convergent by this. Done. No need to do any check. Just I will go to the error. And with that, S minus, so what is AN? 1/5 square root n plus 3. Okay. So I have S minus capital SN. This is the error. That will be, yeah, the error, which is less than, we call it what, A n plus 1. What is it? Yeah. Less than or equal A n plus 1. I want this to be less than 0.05. What is A n plus 1? A n plus 1 will be 1/5 square root n plus 4. And they want this to be less than 5/100, which is 1/20. So I want 5, oops, I need 5 square root of n plus 4 to be greater than 20. Okay. So it means I need square root n plus 4 to be greater than 4. Square both sides, so I need n plus 4 greater than 16. So n should be greater than 16 minus 4, which is 12. So how many terms I need? I need 13 or more, since n should be greater than 12. How many terms? It should be at least 13. Because I want not 12, huh? 13. Because capital N, I want it to be 12. So either you can do the calculation to find N, or you can check it one by one until you get something satisfy the inequality. Yeah. Show that the series is convergent. Now I need to show it's convergent. I think it's very clear. An equal 1/n to the power 6. We're very clear the limit is equal to 0. And an plus 1. An plus 1, which is 1/n plus 1 to the power 6. For sure, it's less than 1/n to the power 6. Yeah, satisfying the conditions. So the series, as alternating series, converges by alternating series test. How many times should we need in order to find the sum of the indicated accuracy? This is the error. So now that S minus S capital N, which is the error, I know is less than AN plus 1, and I want that to be less than 0.00005. Okay, so that means what? That means, yeah, 1/n plus 1 to the power 6 less than, this is what, 5 over what, 1, 10, 100, 11, 100,000, 1,000, 10, 100,000, which is what? Which is 1/20,000. So I want to check when n plus 1 to the power 6 greater than 20,000. I need to check the numbers now. Okay. So if you check, yeah, I think you need a calculator in this case. N equal 5, for example. What will be the answer? Capital N equal 5. No, capital N equal, let me start with a small number. For example, 4 or 3, let me say. Yeah. 3. Then you have what? You need to check 4 to the power 6. You check 4 to the power 6, which is what? 4 to the power 6. Wow. Yeah, not easy to do the calculation. 4 to the power 6 is what? 16 times 16 times 16. Yeah. Let me do it by... Yeah, I think sometimes you need a calculator for that. Or try to do it by multiplication. Times 16. That will be 4,096. Now we take n equal 4. I need 5 to the power 6, which is 25 times 25 times 25. That give me 15,625. Until now, I'm not reaching the 20,000. N equal 5. I have 6 to the power 6. That will be what? 36 times 36 times 36. That is 46,656. So I'm reaching this. So how many terms? At least 5 to reach that accuracy. 5 tenths. Yeah, that was the answer. Another example. We need to check this is converging. Yeah. An is 1 over n squared 2 to the power n. So the limit of an, this is positive, very clear, nothing. Yeah. This is alternating. As n goes to infinity, this is 0, very clear. And they know n plus 1 will be less than n. Very clear, since n plus 1 squared 2 to the power n plus 1 for sure is greater than n squared 2 to the power n, so the reciprocal will be less. So the series converges by alternating series test. Now I need the error. S minus Sn, which is the error, which is I know that less than a n plus 1. I want this to be less than this number. So I have what? 1 over n plus 1 squared, that will be a n plus 1, times 2 to the power n plus 1. I want this to be less than this. Less than 5 over what? 10,000, which is 1 over 2,000. So I want n plus 1 square times 2 to the power n plus 1 to be greater than 2,000. Yeah. Take n equal, for example, what? Take n equal 3. Let me start by 3. I'm getting what? 16 times 16, 256. 16 times 16 is what? Yeah, it is 3 plus 4. 4 squared times 2 to the power 4, which is 16 times 16. I think this is 265. Yeah, it's 265, which is not correct. N equal. When that reach the 2000, n equal 4, you have what? 5 squared, which is 25 times 32. We do the calculation. 35 times 32, you get 800. Still, capital N equal 5, you have what? 36 times 2 to the power 6, which is 64. If we do the calculation, that 2,304. So this is correct. So how many terms we need? At least 5 terms. I think it's very clear. At least 5 terms. Okay. Let me go to some of these all the exams questions, not covering all, just to see the flavor of this section or this part of this section. Essentially, the sum of the nth part of the series, the smallest number of terms. Yeah, this is very clear. It's I have 4 here. Yeah, so this is positive, and the limit of an as n goes to infinity equals 0. An will be 4 over n square. And very clear, n plus 1 will be less than an. Less than an. So all conditions satisfied. So the summation or over n square converges by alternating series test. Now we need the error s minus Sn, which is the error. Yeah, this one I know it's less than or equal an plus 1. And they want that to be less than 0.01. So it will be an plus 1, it will be 4 over n plus 1 square less than 1 over 100. Yeah, then yeah, 100. So you have what? You need n plus 1 square to be greater than 400. So you need n plus 1 to be greater than 20. I know the square root of 400 is 20. So you need n to be greater than 19. N greater than 19. So how many terms we need? The smallest number of terms. What will be the smallest number of terms? Is more than 19, which is 20, an integer number. And that is our answer. Same thing. The minimum value of n, or the smallest number of terms, or yeah, n partial sum approximate the sum with the error this. So we have an using the alternating series estimation theorem. So it means this converge. N is 1 cube root n plus 4. So I want what? I want, I know, the s minus Sn, which is the error, is less than or equal a capital N plus 1, and that I want it to be less than 0.1. So I have 1 over cube root capital N plus 1 cube, capital N plus 1 plus 4 to be less than 1 over 10. So that means I want cube root of n capital N plus 5 greater than 10. That means I need n plus 5 greater than 1000. 10 cubed, which is 1000. That means I need n to be greater than 995. So it will be the minimum value of n will be an integer value more than 995, which is 996. That will be my answer. Yeah. Which of the following series is divergent? Divergent. Yeah. This one alternating, very clear. Limit goes to 0 and an plus 1 less than an. This one same, goes to 0. Yeah. Yeah, you need to do it. If you want to do it in details, you say an 1 over n square, limit an. Yeah, let me write it this way. Maybe it will. An limit an as n goes to infinity and decreasing or not. Yeah, an is 1 over n square. Limit goes to 0. And it's decreasing, yes, very clear. N plus 1 square is greater than n square. This one is the same. The limit will be 0 and decreasing, yes. This one is what? Yeah, don't worry about it. This is minus 1 to the power n minus 1 n cube into the power 5 over 2. Yeah, 3 minus half. which is 6 over 2 minus half, minus 1 over 2, 5 over 2. So I have 1 over n to the power 5 over 2 is equal, the limit goes to 0, and it's decreasing. Yeah, as you increase this. Let me do this one, because this is the answer. I'll go back to it. This is 1 over n to the power half. So this is equal to 0, and it's decreasing. This one, if you notice, it's what? What is an? An will be n minus 1 over n plus 1, and that limit will be equal to 1. So this is diverge. The rest converge by AST. This is converge. Yeah, converge by AST. Yes, 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 yes. This is no. So this is the only one divergent actually by n-term test. N-term test for divergence. Using the alternating series estimation, the minimum value up to 3 decimal places. Okay, this is the error, i.e. the error is like this. So my an is 2 over n square. I want s minus capital Sn, which is the error. I know it's less than an plus 1, and they want that to be less than 0.005. So I have 2 over n, 2 over n plus 1 square, less than 5 over 1000, which is 200. Yeah, so I have what? No, 1 over 100, sorry. It's 1 over 200. So I want n plus 1 square to be greater than 400. So that means n plus 1 greater than 20. So that means n greater than 19. So how many terms? A number, an integer more than 19, which is 20. That will be my answer. Yeah. The series is what? Very clear, it's alternating series. This is alternating series. Yeah, an 1 over n to the power 5. That's alternating series from this. So what is the limit of an as n goes to infinity? That will be 1 over n to the power 5, which is 0. And we know that n plus 1 to the power 5 for sure is greater than n to the power 5. That means 1 over n plus 1 to the power 5, which is an plus 1, will be less than or equal 1 over n to the power 5, which is an. So the two conditions satisfied, then it will converge by alternating series. So this is the correct. The rest are wrong. Is it geometric? No, it's not geometric. Is it divergent B series? No. If we take, yeah, if you take it without minus 1 to the 1, then it will be a convergent because n equal 5. So this is wrong. Convergent B series is not a B series because of this minus 1. Divergent geometric series, no. Okay. It's the same question. Oh, by mistake, I put it. It says the same. Sorry about that. Which one is divergent? Yeah, very clear. If I make it the same way, I make an here, limit an as n goes to infinity. Here decreasing or not. Then I conclude this is 1 over the square root of n equals 0. Decreasing, yes. As you increase the denominator, the number will be decreasing. Yeah, this one, we have clear problem. This is the limit is equal to 1. So So it will diverge. This is what for sure it will diverge. This converge by AST, alternating series test. This is 1 over n. This is well known. So this is 0 and it's decreasing. This is 1 over ln n plus 1. It's also 0 and decreasing. This one n over n squared plus 1. The degree is more, so that will be 0. And I think you can prove easily that it's decreasing. So all of these converge by AST. Same thing for this, same thing for this. Okay. That's the smallest number of terms. Yeah. This is n equal 1 over 2 n plus 1 to the power 4. The limit is equal to 0. And for sure, it's decreasing. Yeah, no need to do the calculation. So the series converge by alternating series test. So what I will do, I need the error S minus capital SN, which is the error. I know it's less than a n plus 1, and I want this to be less than 0.001. I have this inequality so that the error is less than this value. So I have 1 over 2, be careful here, n plus 1 plus 4 plus 1 to the power 4, sorry. But I need n multiplied by 2, so I have all n plus 1, capital N plus 1 multiplied by 2. I want this to be less than 1 over 10,000. So that means I want, be careful here, 2n plus 3 to the power 4 greater than 10,000. So I want 2n plus 3 to be greater than what? This is 10,000. 10,000, which is what? 10 to the power 4. So the fourth root of this will be 10. So I mean 2 capital N greater than 7. So capital N greater than 7 over 2. What is the smallest number? The smallest number of terms. What is the integer? More than 7 over 2 will be 4. That will be my answer. Yeah. Okay. What you're doing series is divergent. I think we did it before. No, except the last one. Yeah, we did something similar. This one converges AST. This one converges AST. This we did it before. Converges AST. We did it before, like in these ones. This one is square root of n ln n plus 1. Okay. This one diverges since the limit is equal to 1. Okay. Here, it will be converged by AST. The limit an is what? N plus 1 over n squared plus 1. And the limit will be 0, decreasing to its your way. Check. I think it's the easiest to do. So this is the correct answer. The rest are converging. Which of the following position is false about this series? Diverges, converges, absolutely converges, converges, alternating series, converges, yeah. Okay. Yeah, we're not talking about absolute convergence. It's only just take the absolute value and check the series. Yeah. Then this series, I'm concerned about the alternating series things. Yeah. Okay. Since we don't have absolute convergence, I will leave this question to the after we discuss absolute convergence. Okay, the smallest number of terms. Yeah, we did these things, and this is very clear. It's converging. It's 1 over n to the power 3 over 2, with the limit n is equal to 0, and an plus 1 is less than an. So this series converge by the alternating series test. So you know that S minus Sn, which is the error, should be less than an plus 1. And that I want it to be less than 0.001, which is 1 over 1000. Okay. What is an plus 1? It's 1 over n plus 1 to the power 3 over 2. Or 3 over 2, I want it to be less than 1 over 10,000. So it means I want n plus 1 to the power 3 over 2 greater than 1000. That means n plus 1 will be greater than 10,000 or 1000 to the power 2 over 3, which is 10 cubed. That gives me 100. So my n will be greater than 99. So the smallest number, of terms, an integer more than 99, so it's 100. That will be my answer. Good to go. Smallest number of terms. Yeah. Yeah, this is very clear, converges. This series, you can check. We did many by alternating series test. Limit goes to 0 and it's decreasing. So I want S minus Sn, which is the error. For sure, it will be less than an plus 1, and I want this less than this. Satisfy that inequality so that the error is less than this. So it is an plus 1. I have 1 over n plus 1 to the power 4 over 3. N is what? 1 over n to the power 4 over 3. That I want it to be less than 1 over 10,000. Okay. So that means n plus 1 to the power 4 over 3 greater than 10,000. I want this. That means n plus 1 should be greater than 10,000 to the power 3 over 4. 10,000 is 10 to the power 4, so with 1 over 4 cancel. So you have 10 cubed, which is 1,000. So n should be greater than 999. So the smallest number of terms is 1,000. An integer more than this, which is 1,000. The smallest number. Yeah, this is converging. Converges by alternating series test. Yeah, very clear to see it. I think so. Yeah. Then, yeah, it goes to 0. This is an over n. So it goes to 0 and decreasing. So I need to check the terms S minus capital Sn, which is the error. I know it's less than an plus 1, and I want that to be less than 0.001. So that means what? I have 1 over n plus 1 cubed minus 1 less than 1 over 1000. So that means we want n plus 1 cubed, n plus 1 cubed minus 1 greater than 1000. So I need n plus 1 cubed greater than 1001. So that means n plus 1 to be greater than cube root 1001. 1001 is what? The 10 cube is a 10 point something. Who cares? That means n is greater than 9 point something. What's that something? I don't care. So it means the smallest number of terms will be an integer more than 9.00, so more than this value, which it should be 10. So this is would be my answer. Yeah, let me stop the recording, and then I will do more. Then I will go to absolute convergence and conditional convergence, explain it, and then we'll do more examples about that. Yeah, let me stop the recording. Thank you.